Hi friends, today we are going to see is a transform of some basic functions. Now we are going to see what is a transform of delta n. What is a transform of delta n? That is your delta n is the unit impulse sequence. This is unit impulse sequence. This delta n is known as the unit impulse sequence and it is defined as delta n is equal to 1 when n is equal to 0 is equal to 0 otherwise. Okay, is equal to 0 otherwise you can write this way or n not equal to 0. This way also you can write it. N is equal to 0 when n not equal to 0. So when n is equal to 0 only, delta n takes the value 1, otherwise it becomes 0. Now we have to find out is a transform of this function. What is a transform of delta n? You have to apply the summation. N is equal to 0 to infinity. Function here is delta n into z power minus n. But according to our definition of this impulse function, unit impulse function, when delta n is equal to 1, when n is equal to 0. So in our summation we have n is equal to 0, 1, 2, 3 etc. up to infinity it will goes. So it take the value 1 when n is equal to 0, otherwise it becomes 0. So we have this value is equal to this is equal to n is equal to 0 no. So this value when n is equal to 0 this becomes 1 and z power n is equal to 0 we have to substitute z power minus 0. We have this is equal to 1. Is it anything power 0 is equal to 1 here. So z transform of delta n is equal to 1. This is the transform of unit impulse sequence. Okay, next we have to find out is the transform of u of n. What is that u of n? Capital U. What is that capital U of n? This u of n is the unit step sequence. Okay, this is known as unit step sequence. This sequence is known as unit step sequence and is defined as u of n is equal to capital U. You have to put it. Okay, u of n is equal to 1 when n greater than or equal to 0 and is equal to 0 when n less than 0. When n takes the negative values, this becomes 0 and n is positive along with 0, it will take the value 1. For n is equal to 0, 1, 2, 3 etc. up to infinity, it will take the value 1. Okay, so now we have to find out is a transform of this unit step sequence. What is z transform of u of n? Z transform of u of n is equal to, as usual, we have to write the definition of z transform. N is equal to 0 to infinity. Function here is u of n into z power minus n. But according to our definition of unit step sequence, when n greater than or equal to 0, that is n takes the value 0 to infinity, this u of n takes the value 1. So here our limit is also n from 0 to infinity. In that case, your u of n is equal to 1 into z power minus n. Okay, so which is equal to, this is equal to z power minus n. We have 1 into this term, you can write n is equal to 0, you have z power minus 0 plus n is equal to 1, you have z power minus 1 plus z power minus 2 plus etc. Or otherwise 1 plus 1 by z plus 1 by z squared plus etc. Or you can write this to be, that is a transform of the summation 1 plus x squared, isn't it? This is the form 1 minus x whole power minus 1, but here x value is equal to 1 by z. Okay, so you can write this to be 1 minus 1 by z whole power minus 1, or otherwise you can write this to be z minus 1 by z whole power minus 1 or z by z minus 1. This is z transform of u of n. Okay, z by z minus 1. When you look at this, what is this one? What is this term z by z minus 1? Which is a transform of when function gives z by z minus 1? Yes, you are right. Z transform of 1 is equal to z by z minus 1. Okay, so instead of this procedure you can write this way also. Here you have, this is the function is a transform of 1, isn't it? Yeah, 1 into z power minus n. So when n is equal to 0 to infinity, u of n is equal to 1. So this is a transform of 1. So what is a transform of 1? Z by z minus 1. This is also you can this way also you can write it or remember the answer. This will be very helpful in doing problems. So you have to remember these two results also. Is a transform of unit step function and is a transform of unit impulse function. You have to remember. Okay. And next we will find is a transform of bilateral. That is bilateral is a transform. We find. Okay. Find the bilateral is a transform of the following. Okay, is a transform of the following functions. Our first problem is you have to find out a power n into delta of n minus k. That is your unit impulse function. Okay, just now we find the result now. So you have to apply that. There when delta n alone is there, here n minus k is there. Let's see how to find the answer. Minus alpha power n into, this is unit step function, minus n minus 1. U of n is step function. N, instead of n you have minus n minus 1. We have to find out the limits for this. Okay. And the next problem is minus n alpha power n into u of minus n minus 1. These are the functions given. We have to find out the bilateral Lizard transform. What is bilateral Lizard transform? Bilateral Lizard transform is we have to apply the limits for minus infinity to infinity. Okay. Unilateral, we are just till this problem we find the Lizard transform, that is unilateral Lizard transform. We are taking the casual sequence when f of n is equal to 0. So your limit varies from 0 to infinity. Summation varies from 0 to infinity. That this is the unilateral Lizard transform of a function or just Lizard transform. Suppose you are asked to find out bilateral Lizard transform, you have to do the procedure. That is procedure. The following procedure you have to do it. A power n into delta of n minus k. We have to find out is a transform of this thing, isn't it? Now we will see, before going to apply is a transform definition, what is delta of n minus k here? Okay, you know that delta of n is equal to 1 when n is equal to 0 is equal to 0. Otherwise, this is your definition of unit impulse function. Okay, in the place of n, it is given as n minus k. So you have to write this to be is equal to 1 when this is equal to, here this is equated to 0, isn't it? Delta of n minus 1 is equal to 1, meaning n is equated to 0. In the same way, this is equal to 1. When it is equal to 1, when this is equated to 0, then value is equal to 1. Okay, so from that n is equal to k. So when n is equal to k only, delta of n minus k is equal to 1. Otherwise, it becomes 0. Okay, so we write this value for n is equal to k. This is the way you have to find out this limit. Okay, and is equal to 0 otherwise, or n not equal to k also you can write it. Okay, now you have to write is a transform of delta of n minus k. What is a transform of delta of n minus k then? Summation, that is you have to go for bilateral is a transform, isn't it? So summation n is equal to minus infinity to plus infinity delta of n minus k z power minus n. Okay, and here why we are applying the limit here is minus infinity to plus infinity. We are asked to find out a bilateral is a transform of the following functions. That's why we have to put the limit as minus infinity to plus infinity. Okay, now we have to apply the definition here. When n is equal to 0, in this infinity, minus infinity to plus infinity, minus infinity to plus infinity, in between you have a k, isn't it? N is equal to k, you have value. In that value alone, it takes the value 1, and remaining values it becomes 0. That is the definition of unit impulse function. Okay, so we have a summation. You have to write like this. Okay, summation n is equal to k only, it will take the value, otherwise it becomes 0. When n is equal to k only, this function takes the value, so no use of writing the summation. Okay, we are just writing only one function, that is only one value, that is k. Okay, so n is equal to k only, it has the value, otherwise it becomes 0. That's why. And this value becomes 1, write it. And when n is equal to k, you have z power minus k. That is z transform of delta of n minus k. Okay. Now, we have to find out z transform of a power n delta of n minus k. We have to find out. Okay. So, what is delta of z transform of a power n delta of n minus k? How will you find that? We know the property. Z transform of a power n f of n is equal to your f of z, capital F of z, as z tending to z tending to a, isn't it? Z tending to z by a, sorry, z tending to z by a, z tending to z by a. Here also we have to apply the same property here. The same property here is the transform of a power n delta of n minus k is equal to, here you have to write the is the transform of that function, isn't it? That is, when k is equal to, you have to write this term f of z is, what is your f of z? Delta of z minus k is your f of z, isn't it? This is your f of z, as z tending to z by, here a is given, so you have to write z by a. What is f of z? F of z is z transform of delta of n minus k. What is your f of z, isn't it? So z transform of f of z, that is, sorry, this is f of z. What is f of z? This f of z is z transform of delta of n minus k. That is known as your f of z. Okay, so we have to apply that result here. So z power minus k as z tending to z by a, or otherwise this value is z by a whole power minus k, or otherwise you can write a by z. That way also you can write it, which is equal to a by z, which is z transform of a power n delta of n minus k value. Is it clear? Now we pass on to the next problem. What is our next problem? We have to find out is a transform of minus alpha power n u of minus n minus 1. Okay, u of minus n minus 1. What is u of minus n minus 1? First you have to write this value. What is the unit step function? Okay, what is the unit step function value? We have to write it. So when u of n, what is your u of n value? U of n is equal to that value is u of n is equal to 1 when n greater than or equal to 0 is equal to 0, n less than 0. This is your unit step function definition, isn't it? But instead of n in our problem, minus n minus 1 is given. So u of minus n minus 1 is equal to 1. When it becomes 1, this value is equal to 1. When it becomes 1, this value greater than 0. N is greater than or equal to 0. So here in the place of n you have n minus 1. Sorry, minus n minus 1. Minus n minus 1 greater than or equal to 0. So you have to write like this. Minus n minus 1 greater than or equal to 0. What is this meaning? What is the value? This value is equal to, that is minus n from this. Minus n less than or equal to, isn't it? Less than or equal to 1. When you're taking minus 1 to plus 1, it becomes your sign is changed, isn't it? So minus 1, that is minus n less than or equal to 1, or otherwise n is less than or equal to minus 1. When n less than or equal to minus 1. So we have to write n less than or equal to minus 1 only. It takes the value 1, otherwise it becomes 0. So here is equal to 0. When it is equal to 0, minus n minus 1 less than 0. What is minus n minus 1 less than 0? You have, that is minus n minus 1 less than 0 implies your minus n greater than 1, or n is greater than minus 1. This minus goes to this side. Okay, so when n is greater, that is, sorry, here you have to write like this. That is n is greater than minus 1. So this is the limit for you have when n is equal to 1 in this case, and n is equal to 0 otherwise. Now we have to find out, is it transform of the unit step function? Is it transform of u of minus n minus 1? We have to find it out, okay, which is equal to, we have to find out bilateral is a transform, isn't it? So your result varies from minus infinity to plus infinity. U of minus n minus 1 is it power minus n, you have to write it. And according to our this definition, unit step function definition, this takes the value 1 when your limit n less than or equal to minus 1, that is minus infinity to minus 1 only. This function takes the value 1, otherwise it becomes 0. Okay, this is plus, this is equal to 1 to infinity, but that is minus 1. After minus 1 you have 0, so 0 to infinity, this becomes 0. Okay, so this is what this one come, this becomes 0 then, is equal to, here this value we have to find it out, or you have this value is equal to summation minus infinity to minus 1 is it power minus n you have, isn't it? Or otherwise you change all the limits, that is n is equal to 1 to infinity, you have to take n is equal to 1 to infinity is it power n. This is same as, this value is same as, both the sides you have to change the sign, and when n is equal to 1 to infinity is it power n, this value is same as like this. Okay, and when you're substituting n is equal to 1 here, z plus z squared plus z cube plus etc. up to infinity it will go, and z you can take outside. So when you're taking z outside, you have 1 plus z squared plus etc. up to infinity you have, isn't it? So this value is equal to z into, what is this expansion? 1 minus z whole power minus 1, or you have z by z minus 1. Sorry, 1 minus z, sorry. Okay, this is equal to z by 1 minus z. This is the z transform of u of minus n minus 1 value. Okay, you have to remember this also. And then, so next we have to find out is a transform of, that is using this we have to find out is a transform of minus alpha power n u of minus n minus 1 value. Okay, so as usual we have to apply the property. What is our property? Is a transform of a power n f of n is equal to, this value is equal to f of z as z tending to z by a. What is this f of z? F of z is a transform of f of n, not a power n, f of n. Is a transform of f of n. This is a transform of f of n is your f of z. Okay, so we had to, in the same way we had to write the is a transform here, that is minus alpha is there. So you have to write this to be, first we find out is it transform of alpha power n. Okay, alpha power n u of minus n minus 1. From that we can easily write the value of this one. Okay, this is minus alpha power n. Okay, so we have what is alpha power n u of minus n minus 1, that is f of z, that is f of z is a transform of u of minus n minus 1 as z tending to z by alpha. In the place of a you have alpha is there, so z tending to z by alpha. Just now we got this value, z transform of minus n minus 1. What is z transform of minus n minus 1? Z by 1 minus z. Okay, as z tending to z by alpha. Here this is f of z, you can write it. What is f of z? F of z is a transform of this function. Okay, that's why we are writing like this. Don't confuse with this. Okay, and then we have to replace z by alpha. z by alpha divided by 1 minus z by alpha, or you have to take the simplify this, z by alpha divided by, you have to take LCM, alpha minus z by alpha. This alpha get cancelled both in the denominator, so these get cancelled. Z by alpha minus z, this is z transform of alpha power n u of minus n minus 1 value. But we have to find out z transform of minus alpha power n u of minus n minus 1 value, isn't it? So you have to multiply this by 1 minus, just that's it. Okay, so minus z by alpha minus z, or you can have this value is equal, you take this minus here in the denominator, z by z minus alpha, which is the z transform of minus alpha power n u of minus n minus 1 value. Is it clear? Now we pass on to the next one. What is our next problem? We have to find out. Our next problem is, we have to find out is the transform of minus n alpha power n into u of minus n minus 1 value. Okay, this is, we have to find out is the transform of this value. Now, what is the transform of, you have to apply the property whenever n is there. Okay, whenever n is there, you have to apply the differentiation property, isn't it? So using the same property, we complete this problem. Okay, so here, before going to start with this problem, we use the definition of, that is property of n into f of n. What is the transform of n f of n? That is minus z d by dz of f of z. Okay, what is f of z? F of z is a transform of f of n. This function you have to write it. Okay, and then what is this value? Is a transform of, we just now find out is a transform of minus alpha power n u of minus n minus 1 value. We just now find out that value, isn't it? What is that value? Z by z minus alpha. Okay, so and we have to find out n into this function, isn't it? Compare these two terms, this one. Compare these two. Here one n is inserted here. So is the transform of minus n into alpha power n u of minus n minus 1 is equal to, whenever n is in the function, n is multiplied by the function, you have to apply this property minus z d by dz of f of z. What is f of z here? This is your f of z, isn't it? Is a transform of minus alpha power n u of n minus 1 is your f of z. Okay, here f of z is equal to, is the transform of minus alpha power n u of minus n minus 1. This is your f of z. So we have, but we know this value. We just now find out that value, z by z minus alpha. Okay, in your exam, this function alone is asked. Depending upon your marks, you have to answer it. Okay, if it is a 2-mark problem, then you have to remember this result and write it. Otherwise, you have to find out this is a transform of this function and you have to substitute it. Okay, so minus z, and we have to differentiate this with respect to z. The numerator by denominator is there, so you have to apply u by v. That is first term denominator into, you have to differentiate the numerator with respect to z. Z with respect to z is 1 minus z into differentiation of denominator with respect to z, that is differentiation of z with respect to z is 1 minus differentiation of constant with respect to z is 0. So this term becomes 1 alone. Okay, and divided by z minus alpha the whole square, or otherwise minus z into, here z minus alpha minus z divided by z minus alpha the whole square you have, which is equal to, this minus z plus z get cancelled and the remaining term minus becomes plus alpha z divided by z minus alpha the whole square. This is bilateral z transform of minus n alpha power n u of minus n minus 1 value. Okay, that's all for this video. If you have any doubts, please provide in the comment section, and also if you need some other problems also, please let me know in the comment section, and I'll try to do the video and give it to you. Okay, thanks for watching. Thanks for your time. Thank you.